80 terawatts of power every single hour. That's how much electricity demand is data centers expect to take up in the coming years. With the increase of constructed data centers and consumption of water, it is a huge problem and a lot of environmental concerns. But what if we could tell you that we can decrease the power consumption by 40% by AI tools? What if I could show you we can power devs by doubling their productivity while halving the environmental costs? Introducing LoopWhole. It's an agent agnostic repo that's it essentially makes the agents that makes agents more token efficient at tool calling without new prompts or lossy summarization. But Thompson, how does that exactly work?
Good question, Enrique. So, how uh, loophole works is essentially we act as an intermediary, a middleman between the agent's to calling and the result of the to calling. So we do state management over the agent. So usually when you say open Claude Code or Codex, which is what most people use, the agent just really its tools gets to use its tools directly over your code base. So that means the agent essentially is treating your code base as like a conversation. So an agent can basically call the same tools over and over again. It can read the same files. It can also run the same commands. And then for each command, it'll have to write the input and then also have the output. So every time it can duplicate that, and that takes up your context window very quickly. And the largest source of token spend is definitely tool calling. So in this case, the agent uses the normal tools usually, but instead of say it just directly getting say the state of a file and then just returning it as a snapshot to the agent, we intercept the call. So after we intercept the call, we process and we manage the state. We check the agent's context. Uh, for edge cases, and then we after that we decide if the agent should actually look at this, and we return the full context that the agent only needs, such that it doesn't get anything else that's excessive. So an example of this is read. We check for several edge cases. So in read, we check for duplicate file reads, and we check for like the previous snapshot versus the newest snapshot of the file, and see if there are like new changes. Edit is perfect. We don't change anything. Write, we make sure that like agent only uses write for creating new files instead of say like writing a patch, which in the case that they do, we redirect them to use edit. And then we also have bash, which we use to manage the output of commands to make sure that the same commands don't overflow your context window. And then for command edit, we've noticed that coding agents these days, they really like writing one-shot Python scripts, and then we've decided to implement a nice little function that lets them reuse existing commands that they've written using a relative diff based on the edit tool. So that's enough talking about it. So let's get into the demo. So so I'm gonna run my open code instance because I love open code, and let's get into it. So now we're gonna wait for two calls, and because prompting is boring and you don't want to watch me type probably, I have some prompts ready here. So I'm currently in a Rust code base with around approximately 3,000 lines of code. My friend literally just like got me on this project. I don't know anything about it, so I'm gonna have the agent help me out and run some tests, figure out what the code base actually is. So so I'm just having a check, and the agent is using our MCP tools, which we are middlemaning. So it runs, and you can see that. So on the left here is the original to output. On the right here is our to output. So instead of just directly outputting what the command runs and into the context window, we only look at what matters to the agent enough for it to make a choice or to reason. And then that's all it needs. And you notice here we have a command ID, and that's for reusing the bash commands. So let's run a couple more. Uh, and it's run. And as you can see, because there was no change in the command, we just output no change, and that's literally it. And that saves us 88.58% of tokens for running commands. Uh,